So what we use in this case is the least squares fit. And this is a method where what we do is we find a line best fit basically, and we take the distance between the vertical distance or like up, or the vertical distance down between the line of best fit and each point, and we square it. And each of these points is called the residual or the vertical deviation. And for the points above the line of best fit, they're going to have positive residuals. And for the points below the line of best fit, they're going to have negative residuals. And if you actually take a look at these boxes, so for example, I'm going to do this example here. This point is 1, 2, like 2 units, whatever the units are on this scale, 2 units up. So in order to square it, we have to make 2 by 2, right? So if you can see, the bigger the box here, this is just a visual representation, but the bigger the box here, so this is like half up, half over, half down, half over, maybe 1.5 down, 1.5 over. The square, what this means is like the more of the residual, so like the further away from the line of best fit it's going to be. And for the line of best fit in the least squares method, the sum of the residuals is 0. The positive and negative residuals cancel out. And the sum of the squares of the residuals has the least possible value. Okay, what we're going to find basically is y equals ax plus b. Very similar to grade 9, y equals mx plus b, okay, where a equals this long equation, and then b equals y bar minus ax bar. And again, x bar is the average of the x's, y bar is the average of the y's. Okay, so for example 1, applying the least squares formula. For the following table, so we're going to take a look at a table on the next page. The following table that shows the annual income of full-time employees of a small company. Use the scatter plot to classify the correlation between age and income. Okay, so let's do that first, and then we're going to find the equation analytically. And then we're going to do some predictions, so like some interpolation and extrapolation. So it is these points that we're actually going to graph. So 33, 33, 25, 31, and so on. So we're going to graph years against annual income. Okay, so this is going to be years along the x-axis, and then along the y-axis is going to be annual income. Annual income. Okay, and if we take a look at the numbers, the age in years, I should say, and the annual income in dollars. Okay, the age in years has to go up to, it looks like 54. So let's go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. That's good. And then the annual income in 000, so in thousands, has to go up to 60. So we'll do the same thing. 10, 20, 30, 40, 50, 60. Here we go. Okay, I'm going to go ahead and graph this, but I'll pause the video. Okay, so I just graphed all the points. Now let's just see, let's try to classify this correlation. So for me, this is what I see. I see that as the number of years increases, so does the annual income. And I would get line of best fit approximately here. So this goes through as many points as possible, and then we have like 2 on this side and maybe 2 on the other side, right? Okay, so I would say for A, as the years with a company, so as the years increase, the annual income increases as well. Okay, so let's actually now find the equational line of best fit analytically. So if we remember, I'll skip back here. If we remember, A equals the sum of, so we have to do x, y, we have to do x's, y's, and then just x squareds. So the only thing new that we have to do is x, y, and x squared. It's a little bit less than in 3.1. Okay, so for the age, what you want to do is you want to add them all up, and I'm going to put the total right here in these boxes at the bottom. So I'm going to go 33, 25, 19, 44, 50, 54, 38, 29. I get 292. And then for annual income, remember this is in thousands. 33, 31, 18, 52, 56, 60, 44, 38. I get 329. So what I want to do here for the XY is just 33 times 33. What I want to do here is 25 times 31. 25 times 31. And all the way down, 19 times 18. And I'm not going to fill all of these in. I just want to show you where the X times Y comes from. And then I'm going to actually calculate it. So 33 times 33, I get 1,089. 25 times 31, I get 775. And 19 times 18, I get 342. Okay, I'm going to do that for the rest of this column. And then what I'm going to do is x squared. So we just go to the x column, which is here. This is x, this is going to be y. We want to do 33 squared. And for this one, we want to do 25 squared and go all the way down this column. Okay, so these are the numbers that I get for these boxes. And now what I want to do is go down this x, y column, and I'm going to add all the x times y's together. So I'm going to go 1089 plus 771 plus 342 plus 2288 plus 2800, 3240, 1672, and then 1015. At the bottom, I get 13,000. 217. Now, same thing for the x squareds. I'm going to go down the entire column. 29, 16, 1, 4, 4, 4. Okay, and I get 11,712. So I'm going to go back and get the equation. Let's just do all of them. I'm going to paste it here. There we go. So now let's actually sub these numbers in to this equation for A. Okay, so long equation, A equals. So the number of values we have, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 times the sum of the xy's, which we found to be 13, 217. Then we have minus, and then we're going to multiply the sum of the x's times the sum of the y's. So sum of the x's, which is here, 292 times 329. So 292 times 329. And that's going to be all over. I'm going to continue in the next video.